Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session we are going to discuss the moment of inertia of a semicircular section. Actually, here I had drawn a circular section. First, we are going to discuss the moment of inertia with respect to the x-axis and y-y axis passes through the center of gravity of the circular section. From that, we will derive the moment of inertia of a semicircular section. Okay. So here there is a circular section is given. And here you can see the center of gravity of the circular section. That will be here. So this will be the x-axis axis passes through the center of gravity. This will be the y-y axis passes through the center of gravity. Okay. So first, for circular section. Okay, guys, here first, I'm going to write the formulas of the circular section. Moment of inertia about an axis x-axis or horizontal passes through the center of gravity, that I'm going to mention as IG x-axis. That will be pi by 64 into d power 4, where d is the diameter. Okay, d is the diameter of the circle and r is the radius of the circle. So here you can see, if you substitute the diameter equal to 2 times the radius, the same formula we can write as pi by 4 r power 4. Okay, any one of the formula we can use. Same way, we know that moment of inertia about an axis y-y passes through the center of gravity IG y-y, that equal to same, because symmetry with respect to the x-axis and y-y axis. So IG x-axis or IG y-y, both the values are same here. Okay. So we can take pi by 64 d power 4 or pi by 4 r power 4. This is for the circular section. Okay. Now, what about the semicircular section? Here, first of all, I'm going to erase half portion of the circle. Okay, half portion of the circle, like this. Okay, previously we discussed for the circle. Now we are going to derive the same moment of inertia for a semicircular section. Okay, so here I erased half portion of the circle. Now it will become a semicircle. Here, guys, you can see there is no change. There is no change in the vertical or YY axis. Same, XX axis also there is no change as of now, because from the circle, when you erase the half portion, when it becomes the semicircle, the center of gravity will not be here. The center of gravity will be shifted to here. Center of gravity will be shifted to here. Now, this will not be a center of gravity. Okay, this will not be a center of gravity. I just erase this. Okay. When you remove half the portion, the center of gravity will be shifted to here. Okay. So, and we know the distance also. This distance is equal to 4r divided by 3 pi. Okay. That is for the semicircle, the vertical distance. Okay. From here to, okay, from here to here, that will be 4r pi 3 pi. So now this won't be the horizontal or XX axis passes through the center of gravity. So now I'm going to mention this as an axis AB. Okay. I'm going to mention this is the axis AB. And now I'm going to draw the axis XX, which passes through the center of gravity now. Okay. So guys, first we consider a circular section. For that, we noted the moment of inertia formulas with respect to the XX and YY axis passes through the center of gravity. For the circle, the center of gravity was here. When I erased half the portion of the circle and converted that into the semicircle, the center of gravity is shifted from here to here. Okay. The distance will be 4r pi 3 pi from the base of the semicircle. Now, the XX axis passes through the center of gravity I drawn here. Okay. So here you can see the IYY. There is no change from the previous circle or semicircle. So for a semicircular section, for semicircular section, okay, IYY or IGYY, okay, moment of inertia with respect to the YY axis, which passes through the center of gravity. Okay, this is moment of inertia about an axis YY or vertical passes through the center of gravity of the semicircle. Okay, now the center of gravity is shifted now. For make some difference, I just mentioned here. That will be, previously it was pi by 64 d power 4 or pi by 4 r power 4 in terms of radius. Okay, now we are going to take this radius formula. So when for the circle, if it is pi by 4 r power 4 and there is no shifting of y axis for semicircle or circle. Okay, so here the only change is half the portion of the circle has to be removed. So the moment of inertia about an axis y through the center of gravity for semicircle is half the value of the same moment of inertia about an axis y through center of gravity, what we discussed here. Okay, here half the portions are removed, so the formula will be half of the formula of the circle. So half the value of pi by 4 r power 4. So we can write this as pi by 8 r power 4. Okay, this is we calculated for moment of inertia about an axis through the axis y through the center of gravity. Okay, now we know that the IAB also there is no change. Okay, IAB also there is no change. Okay, because this MI moment of inertia about an axis AB, that means base of the semicircle. That is also, that will be the previous IXX. And then that is now shifted into IAB. That is also off of the previous XX axis. Okay, previously, here you can see, I erased the XX axis and I noted as AB. Okay, so this IAB also half of the value what we discussed for IGXX. Okay, the half value is for only because the half portion is removed. So the IAB also half of the value of pi by 4 r power 4. Okay, so we can take this also pi by 8 r power 4. Okay, so now we are going to calculate the same thing or moment of inertia about an axis XX passes through the center of gravity. Okay, but here we can use the parallel axis theorem. Okay, so here we calculated the moment of inertia about an axis AB base of the semicircle, that is IAB, that equal to half of the moment of inertia of previous XX axis pi by 4 r power 4, that is pi by 8 r power 4. Okay, so moment of inertia with respect to this axis AB, that we know, and we have to calculate moment of inertia about an axis XX passes through the center of gravity of the semicircular section. Okay, that we can mention as IG XX. Okay, that we need to calculate. We know that as per the parallel axis theorem, okay, as per the parallel axis theorem, IAB that equal to IG plus AH square. Okay, this IG is this IG with respect to the XX axis. Okay, here IAB, that is the moment of inertia with respect to this axis AB that we calculated already. Area of the semicircle, that also we know, because area of the circle is pi r square. So area of the semicircle is pi r square divided by 2. And h, here h is the vertical distance between these two axes. It is actually the distance 4 or pi 3 pi from the base to the center of gravity, that is h here. Okay, so we know this IAB. Okay, we know this IAB, area, and also h. So we need to calculate IG. Okay, so we can write this as IG XX that equal to IAB minus AH square. Okay, here IAB that we calculated as y by 8 or power 4 minus area of the semicircle pi r square divided by 2 multiplied with the h, that is the distance between these two axes, that is 4 or pi 3 pi the whole square. This square is only for h, not for area. Okay, so if you simplify all the values and substitute the value of pi equal 3.14 or 22 by 7, finally we will get the answer 0.11 or power 4. Okay, so IG XX, moment of inertia about an axis XX, passes through the center of gravity of the semicircular section, that will be 0.11 or power 4. That is the final simplified answer. Same for semicircular section, moment of inertia with respect to the YY axis passes through the center of gravity, that will be pi by 8 or power 4. But in this here, if you substitute the pi value 3.14, okay, or 22 by 7 and divided by 8, we can get an value 0.393. Okay, 0.393 or power 4. Okay, so finally we can write IG XX That is, moment of inertia about an axis xx passes through the center of gravity of the semicircular section. Okay, that will be 0.11 or power 4. IGYY, this one. Okay, this one. So that will be pi by 8 or power 4. But if you substitute pi equal to 3.14 and if you simplify, then we will get 0.393 or power 4. Same way, the IAB, okay, not only the moment of inertia with respect to the YY axis passes through the center of gravity, moment of inertia about an axis AB, okay, moment of inertia about an axis AB, that means which passes through the base, okay, that is also pi by 8 or power 4. It means that the same answer you will get 0.393 or power 4. So IGYY or moment of inertia with respect to the axis passes through the base IAB, that is also 0.393 or power 4. Okay. So finally, first we calculated or we noted the formula for the moment of inertia for for circular section. First we calculated the moment of inertia or we noted the moment of inertia formulas. Okay, for a complete circular section, moment of inertia about an axis xx through the center of gravity IGXX, that will be pi by 64 d power 4 or pi by 4 or power 4 into where d is the diameter or is the radius, and we know that diameter equal to 2 times the radius. Then moment of inertia about an axis YY passes through the center of gravity, that is IGYY, that equal to pi by 64 d power 4 or pi by 4 or power 4. Same. Then we erased half the portion of the circle and that become semicircle. Here YY axis will be same, passes through the center of gravity, and when we erase the half portion of the circle, the center of gravity will be shifted from here to here, because for a complete circle, center of gravity will be here. But for a semicircle, when I erase half portion, that will be shifted from this point to this point. That distance is 4 or pi, 3 pi. Okay. So now for semicircular section, with respect to the YY axis, there is no change because the axis is not changed. So only the thing is half the portion removed. So what is the previous answer? Now for semicircle, it will be half of the value that we calculated. And finally, when you simplify the pi by 8, we get 0.393 or power 4. Okay, that is moment of inertia with respect to the YY axis. Here there is no problem. Same way, moment of inertia about an axis AB, that is base of the semicircle, that is 1 by 2 multiplied with pi by 4 or power 4. That is also same like this. Okay, half of the previous value of xx axis, previous xx axis passes through the center of gravity. That is also pi by 8 or power 4. When you simplify, we will get 0.393 or power 4. Okay. Now, only the thing is, we have to calculate the new xx axis passes through the center of gravity of the semicircle. Okay. For that, first we had taken moment of inertia about an axis xx. Okay, this is the final answer what we discussed. Okay, moment of inertia about an axis xs passes through the center of gravity that we have to calculate by using the parallel axis theorem. IAB, okay, IAB that equal IG or IGXX plus AH square. We know the area of the semicircle, that is pi r square by 2. Okay, for a circle if it is pi r square, for semicircle it will be half of the area. So if you convert or interchange this IG and IB, this IGXX that will be IAB minus AH square. Now IAB value we have substituted, area of the semicircle we have substituted, h, that is the distance between the axis AB and xx. Okay, that will be 4 r pi 3 pi. Substitute and square. Now IGXX and simplify, substitute the value pi equal to 3.14. We will get 0.11 r power 4. Okay, so finally, moment of inertia with respect to the xx axis passes through the center of gravity, that will be 0.11 r power 4. Same way, moment of inertia with respect to the yy axis passes through the center of gravity, or moment of inertia with respect to the axis AB, which passes through the AB of the semicircle, also equal to 0.393 r power 4. Okay. Okay, guys. I hope you understand clearly. Don't forget to subscribe. Thank you. Subscribe for more videos. Thank you.